Section 11.7 is on standard deviation. Measures of variation describe how the values in a set of data are spread out. The range and the interquartile range are two measures of variation, and the variance and the standard deviation are two others. They show how much the data values deviate from the mean. The Greek letter sigma represents the standard deviation, and sigma squared represents the variance. Here's how to calculate each one of those. To find the variance, first thing you want to do is to find the mean of the set of data. Remember, that's just the average. Then find the difference between each data value and that mean. Square each of those differences, and then find the mean of these squares. To find the standard deviation, we're going to find the variance as we did up above, and then take its square root. Here's what that looks like when you're doing it by hand. So here's a set of data. Scroll on down here. Okay. Oops. Okay, and this example says, find the mean, the variance, and the standard deviation of the following set of data: 52, 63, 65, 77, 80, and 82. To do this by hand, you would make a table that looks something like this. So here I have my column of x's, which are just my data values. And then I went ahead and I calculated what the mean was. So I added all of those up and divided by 6, and I got 69.83. The next column shows what I get when I do x minus x bar. So 52 minus 69.83 is negative 17.83, and so on. Then the last column here is x minus x bar, that quantity squared. So what is negative 17.83 squared? That's 317.91. Okay, so that's kind of tedious and a lot of things to do. But now remember, to find the variance and the standard deviation, I need to find the mean of all of these values. So I'm going to total that up, and that came out to 690.84. And then when I divide that by 6, that gives me approximately 115.14, and that is my variance, 115.14. And then to find the standard deviation, I'm going to take the square root of that, and that gives me approximately 10.73. So my standard deviation is about 10.73. And remember, that tells me how much the data values vary from the mean. Now that's pretty tedious, especially if you have a very large set of data. Fortunately, we can do this on the calculator. So let's go ahead and take a look at how to do this. As we did in the last lesson, we're going to use the Stat button and the Edit menu, and we're going to enter the values into our first list, into L1. And then in Stat, we choose the Calc menu, and we're going to do one variable stats. Let's take a look at an example of that. The table below shows the number of hurricanes in the Atlantic Ocean from 1992 to 2006. Use your calculator to find the mean and the standard deviation. So in order to do that, I'm going to go to my calculator, and I'm going to enter those values into list 1. So remember, hit the Stat button, and if I hit enter, unfortunately I still have my values in there from the last section when I put those in for an example. So I need to clear those out. Let me show you how to clear those values. So go back to Stat, and you'll notice number 4 here is Clear List. So I'll hit 4. And now I need to tell it which list to clear, and you'll notice above the 1 button there's a blue L1. So if I do second 1, now I'm telling it to clear list 1, hit enter, and when I go back to Stat and hit enter, I'll see that list 1 is empty. So I'm going to go ahead and enter all of those values from that table. Okay, so I have entered all of those values from the table into list 1. Now I'm going to hit Stat, go over to Calc, and select number 1, one variable stats. And this is working off of list 1, so let's go ahead and arrow down to calculate. One more, and hit enter. And I was asked to find the mean and the standard deviation, so here's the mean right here. X bar is 7.26 repeating. I think I'm going to round that to 7.27. And if I go down here and find sigma, that's this value right here. So 3.213 and so on. I think maybe I'll round that to 3.21. So for this set of data here, My mean was 7.27, and my standard deviation, my sigma, was approximately 3.21. Now, every set of data, every value falls within some number of standard deviations of the mean. So for example, if my mean is 56 and the standard deviation is 12, then a value between and including 44 and 68 falls within one standard deviation of the mean. That is, 56 minus 12 is 44, and 56 plus 12 is 68. So all of those values between and including 44 and 68 are within one standard deviation of the mean. So, using the hurricane data above, within how many standard deviations of the mean do all of the data fall? So I'm going to draw a number line here and kind of graph this. And so my smallest value was a 3 and my largest was a 14. So I'm going to take each value in the table. So the first value was 4, and I'm going to put an X over the 4. My second value was a 4, so I'll put another X over the 4. My third was a 3, and I'm going to continue doing that. Okay, so here's what my finished graph looks like. Each X over a number represents that data value. Okay, so previously I found that my standard deviation was 7.27. So I'm just going to draw, my mean was 7.27. So I'm going to draw kind of a line right about there. Okay, so that's my mean. That's my X bar is right there. Okay, now one standard deviation, that was about 7.27. So one standard deviation above is going to be that value plus my standard deviation of 3.21, which gives me about 10.48. So one standard deviation above that, so one sigma, is 10.48. So that was my mean value here plus the standard deviation. Now let's subtract that standard deviation and find the value down here. That's going to give me 4.06. So that's right about here. So one standard deviation below that, oops, that's a really bad sigma. Let's try that again, is going to be 4.06. Okay, so this distance here is 3.21. This distance here is 3.21. Now let's go up 2 standard deviations. So I'll add another 3.21 to this value, and I get 13.69. So let's do that right here. So 2 standard deviations is right here at 13.69. And then let's subtract another one going this way. And that's going to give me something off the chart, which is 0.85, so that's all the way over here. Didn't end up on my graph, so 2 standard deviations in this direction is 0.85. Now, what is it asking? Within how many standard deviations of the mean do all of the data fall? Well, I think I need to go out to another standard deviation because I have a data value here at 14. So let's add another 3.21, and that's going to give me a value out here at 3 standard deviations of 16.9. So all of the data fall within 3 standard deviations. I'll go ahead and write that out. Of the mean. So in this section we took a look at measures of variation that describe how spread out the values in a set of data are. We looked at the variance and the standard deviation, how to calculate those by hand, but even better, how to calculate that on the calculator, and showed what that means in terms of using the standard deviation to evaluate a set of data.